Today we will do the question from 3.6 to 3.18. Question 3.6 is, in the button cells widely used in watches and other devices, the following reaction takes place. Zinc solid plus Ag2O solid plus 2H2O liquid to give Zn2 plus aqueous plus 2Ag solid plus 2OH negative aqueous. We have to determine the delta G naught and E naught for the reaction. Actually, this question is in NCERT, but these values are not given. But when question comes in board exam or any other exam, these values should be given to you. Zinc to zinc 2 plus 2 electron, E naught oxidation, or sometime E naught reduction. Ag2O solid plus H2O plus 2 electron to 2 Ag plus 2 OH negative, E naught reduction, that is 0.344. It should be given to you. Now let us solve it. First tell me, E naught, how do we calculate E naught cell for the given reaction? What is the formula to calculate E naught cell? Yes, beta. E naught cell is equal to E naught cathode minus E naught anode. These E naught are reduction potentials. Reduction potential of cathode minus reduction potential of anode. Now E naught cathode. What is cathode? This one, Ag2O to Ag, that is cathode. And what is anode? Zn2 plus 2 Zn. These are the reduction potential values. See, E naught oxidation is this one. So what is E naught reduction? That is this cell, Zn2 plus 2 Zn. So value is minus 0.76 volt. Just put the value 0.344 minus 0.76. That is E naught cell is equal to 0.344 plus 0.76. So what is the value? 0.76 plus 0.344. That is 1.104 volt. Once again, I repeat, E naught cell is, what is E naught cell? E naught reduction of cathode minus E naught reduction of anode. Okay, and if at cathode reduction takes place, that's why it's positive value. At anode oxidation takes place, that's why it is minus E naught reduction. Otherwise you can write it as E naught reduction of cathode plus E naught oxidation of anode. This is the way to calculate E naught cell. This is the formula to calculate E naught cell. E naught reduction at cathode minus E naught reduction of anode. Or if E naught oxidation is given at anode, then you can write E naught reduction of cathode plus E naught oxidation of anode. Okay, so this is the answer of this question, that E naught for the reaction. Now delta G naught. What is the formula to calculate delta G naught? Yes, beta. Delta G naught is equal to, what is delta G naught? Standard gives energy. Standard gives free energy. And what is the formula for it? Yes, beta. Delta G naught equal to, yes, okay. I said E naught cell. Understood? E naught cell equal to E naught reduction minus E naught reduction of cathode and anode. Means E naught cathode minus E naught anode means standard reduction potential of cathode minus standard reduction potential of anode. But if standard reduction potential of cathode and standard oxidation potential of anode is given, then what we do? We add them, because at cathode reduction takes place and at anode oxidation takes place. Okay, this is the way. Okay, got it? Yes, beta. Okay, now next part is delta G naught. So delta G naught is related to E naught cell, and the relation is, yes beta, what is the relation? What is the relation between E naught and delta G naught? Delta G naught equal to minus NF E naught cell. Minus NF E naught cell. This is the relation. Delta G naught and E naught cell. They are related like this. What is the N? Number of electrons transferred. Now see, in this case, number of electron transferred is, say, zinc 2 plus. How many electrons are involved? 2. Ag2O2, 2 Ag. Electrons involved are 2. That means N for this particular reaction is 2. Number of electrons gained or lost. You can write it as number of electrons gained or lost. So N for this particular reaction is 2. Okay. And F is Faraday. And this Faraday is charge on 1 mole of electrons. Charge on 1 mole of electrons. So charge on 1 mole of electrons equal to approximately, very good, 96500 Coulomb. Now next part is E naught cell. So E naught cell is equal to, just we have calculated, it is 1.104 volt. 1.104 volt. Okay. Now delta G naught, it is equal to minus 2 into 96500 Coulomb and 1.104. It is Coulomb per mole, you know, and 1.104 volt. So Coulomb volt is joule. So result comes in joule. So value is 2 into 96500 into 1.104. That is 213072. 213072 joule. Or in kilojoule, it is 213.072 kilojoule. This is the value. 96500 into 2 into 1.104. So this is the value in kilojoule, or to write in scientific notation, it is 2.13072 into 10 raised to power 5 joule. That's it. So this is the question number 3.6 of NCERT, exercise of electrochemistry. Right? Now next question. 3.7. Define conductivity and molar conductivity for the solution of an electrolyte. So root of this conductivity and molar conductivity is resistance and resistivity. Resistance is proportional to, what is the relation between resistance and resistivity? Resistance is proportional to length. If in the electrolyte, the length of the solution divided by area of cross section. Okay, so L upon A. That implies the resistance equal to rho, that is constant of proportionality, into L upon A. L upon A is actually cell constant. L upon A is cell constant. Now, this rho is resistivity, or we can say specific resistance, because this is the resistance when length is 1 centimeter and A is area of cross section, that is 1 centimeter square. Means it is the resistance of 1 centimeter cube of the solution. Okay, so now if G is conductance, that is written in NCERT, so we take it as G, that is equal to 1 upon resistance. And what is conductivity? That is kappa. It is known as kappa, that is equal to 1 upon resistivity. Just we reciprocate. 1 upon resistance equal to 1 upon resistivity into 1 upon L upon A. So this is conductance. 1 upon resistance is conductance, that is equal to 1 upon resistivity, that is conductivity, divided by L upon A. Okay. So now definition of conductivity. Conductivity, or we can say specific conductance, is the conductance when length of the electrode, or length between the electrodes, length between the electrodes is 1 centimeter, and area of cross section of solution is 1 centimeter square. Means conductivity, it is the conductance produced by all the ions present in 1 centimeter cube of the solution. This is the definition. It is the conductance produced by all the ions present in 1 centimeter cube of the solution. And second part is discuss their variation with concentration. See, on dilution what happened? If we dilute the solution, then what would happen? On dilution, number of ions per unit volume, number of ions per unit volume decreases. So obviously conductivity decreases on dilution. Means if we decrease the concentration, then conductivity decreases, and if we increase the concentration, conductivity increases. So what is the relation? Conductivity is proportional to the concentration of the solution. Conductivity is directly proportional to the concentration of the solution. Now molar conductivity. The conductivity is denoted by kappa. Conductivity is denoted by kappa, and molar conductivity, it is denoted by lambda, capital lambda m. Okay, so molar conductivity is, it is the conductance produced by all the ions produced by 1 mole of the electrolyte. See, molar conductivity. So it is the conductance produced by all the ions produced by 1 mole of the electrolyte in a given volume V. In a given volume V. Okay. In a given volume V. Okay. So actually molar conductivity is equal to conductivity into volume. See, what is the formula? Molar conductivity is conductivity into volume. Second thing, see, what is the unit? What is the unit of resistance? Unit of resistance is ohm. Unit of resistance is ohm. So what is the unit of conductance? Unit of conductance is per ohm. It is also known as MHO or Simon. Means it is denoted by capital S. This is the unit of conductance. Now what is the unit of conductivity and resistivity? So see, resistance is rho L upon A, right? So rho is distance upon L upon A. So resistance is ohm, and it is also written like this, ohm. Okay, and L is, if it is centimeter, so A is centimeter square. So it is ohm upon per centimeter. So centimeter divided by centimeter square. So per centimeter means it is ohm centimeter. That is the unit of resistivity. Now conductivity. So conductivity is 1 upon resistivity. That is unit is 1 upon ohm centimeter, or we can say it is per ohm per centimeter, or we can write it as ohm inverse per ohm per centimeter, or MHO per centimeter, or we can say S per centimeter. Is S per centimeter. In SI it is S per meter. In SI it is S per meter. Same Conductance, resistivity ohm centimeter. In SI, it is ohm meter. So these are the units of resistivity and conductivity, resistance and conductance. Now come to molar conductance or molar conductivity. So in molar conductivity, what is the unit? See, if it is S centimeter square per mole, molar conductivity is S centimeter square per mole. Means what is the unit of kappa? S per centimeter. So volume is, what is the unit of volume? It is centimeter square per mole, because 1 mole is present in a given volume V. V is in centimeter cube. So centimeter cube per mole. So that is the unit. Okay. Now, if V is volume of solution containing 1 mole of electrolyte. Okay. V is the volume of the solution containing 1 mole of the electrolyte. So V is equal to, now concentration. What is concentration? Number of moles over volume of the solution. So number of moles are 1, and what is the volume? V centimeter cube. That means C is 1 upon V mole per centimeter cube, or we can write V as 1 upon C mole per centimeter cube. V equal to 1 upon C, and C is in mole per centimeter cube. So now molar conductivity in S centimeter square per mole, that is equal to K in S per centimeter into V. So that becomes divided by C in mole per centimeter cube. But you know, molarity is in mole per liter. What is the unit of molarity? Mole per liter. So we can write it as kappa S per centimeter divided by molarity in mole per liter. So then it is multiplied by 1000 centimeter cube per liter. See the relation. How do we go from lambda m k into V to this formula? Is molar conductivity in S centimeter square per mole, that is equal to kappa in S per centimeter into 1000 over molarity. Means if molarity is given to us in mole per liter, we should multiply it by 1000. So this is the relation for molarity. Okay, this relation we will use in the coming questions. Okay, now molar conductivity definition we have written. Now what is the variation with concentration? So on dilution, you know, conductivity decreases, but what about volume? You know, 1 mole of electrolyte is in V volume. Okay. Now, when we dilute the solution, means we are adding solvent. Solute remains 1 mole, but solvent increases. That means now V increases, but volume increase is more. Conductivity decrease, that is less. So on dilution, conductivity decreases, volume increases, and that's why net result is molar conductivity increases. So molar conductivity increases on dilution. Molar conductivity increases on dilution. So that is the answer of question number 7. 3.7. Now come to 3.8. 3.8. Conductivity of 0.20 molar solution of KCl. Conductivity of 0.20 molar solution of KCl at 298 Kelvin is given to us in S per centimeter. To calculate its molar, molar conductivity. So what is the relation? Yes, madam. What is the relation? Molar conductivity in S centimeter square per mole, that is equal to conductivity in S per centimeter divided by, because molarity is given, so molarity in mole per liter into 1000. Just put the values. It is 0.0248 in S per centimeter multiplied by 1000 divided by molarity, and that is 0.2. So it is just multiplied by 1000, 24.8. It is in mole per liter. It is in centimeter cube per liter. 24.2 over 0.2, that is 248 by 2 means 124. So that means molar conductivity is equal to 124 S centimeter square per 124 S centimeter square per mole. Yes, beta. Any doubt up to this? Hello. Any doubt up to this? Okay. So now question number 3.9. The resistance of a conductivity cell containing 0.001 molar KCl solution at 298 Kelvin is given to you. Means resistance is given to you. Resistance of a conductivity cell containing 0.001 molar KCl solution at 298 Kelvin is given to you. Resistance is 1500 ohm. So what is the cell constant? You have to calculate the cell constant. Cell constant we have to calculate. What is cell constant? L upon A. And if conductivity of same cell is given to you, conductivity is 0.146 into 10 raised to power minus 3 S per centimeter. Distance is given, conductivity is given. We have to calculate cell constant. So see, resistance equal to resistivity into L upon A. This is the formula. Now, distance equal to resistivity into cell constant. L upon A is cell constant. That implies cell constant is distance upon resistivity. Distance is given, but resistivity is not given. What is given? Conductivity. So you know 1 upon resistivity is conductivity. So resistance into conductivity. That is the formula. Now resistance is 1500 ohm and conductivity is 0.146 into 10 raised to power minus 3 S per centimeter. What is S? S is per ohm. So ohm and S cancelled out means answer is in per centimeter. So value comes out to be 1500 into 0.146, that is 219 into 10 raised to power minus 3 per centimeter. Means 0.219 per centimeter. That is the cell constant. That's it. So this is the question number 3.9. 10th question we will do it separately because there is a we have to plot a graph in it. So 10th question we will do it separately. Now question number 11. Okay, so question number 11 is conductivity of 0.00241 molar acetic acid is given to you. Means first of all concentration is given, means molarity is given. Molarity of the solution is given and it is 0.00241 molar. Molarity of the acetic acid. Second thing, conductivity is given. Conductivity is 7.896 into 10 raised to power minus 5 S per centimeter. Okay. Next, lambda naught is given. Lambda naught is molar conductivity at infinite dilution. It is 390.5 S centimeter square per mole. So we have to calculate what is its dissociation constant. We have to calculate dissociation constant of acetic acid. So we start from here. We know that dissociation constant is C alpha square over 1 minus alpha. Is what we need, C and alpha. Required is C and alpha. You know, C we have the C, molarity of acetic acid. Alpha is not given. That means we have to calculate alpha. And alpha is equal to lambda MC divided by lambda m naught. Lambda m naught is given to you. That is 390.5 S centimeter square per mole. And lambda MC that we have to calculate. So start from here. Is dissociation constant. To calculate dissociation constant we need C and alpha. C was given to us but alpha is not given. So to calculate alpha we use this relation, that is molar conductivity at any concentration divided by molar conductivity at infinite dilution. So molar conductivity at infinite dilution is given to us, but molar conductivity at given concentration we have to calculate, and the formula is, formula we have just derived, s centimeter square per mole. See, lambda m naught is in s centimeter square per mole, so we need the lambda m c in the same unit. So kappa is required in s per centimeter. Molarity is given to you, that is in mole per liter, and it should be multiplied by 1000, that is centimeter square per liter. So what is K? 7.896 into 10 raised per minus 5 into 1000 divided by molarity, and that is 0.00241, right? So now just multiply 7. What we have, 7.896 into 1000, or simply write 7.896 divided by 0.00241. It is 3276.4. 3276.4 from this part. So 10 raised per minus 5 and 10 raised per 3. So into 10 raised per minus 2 means it comes out to be 32.764. Okay, so lambda mc. Now lambda m c equal to 32.764 s centimeter square per mole. Okay. Lambda m naught we have, that is 390.5 s centimeter square per mole. From these two values we calculate alpha. So alpha is 32.764 divided by 390.5. So it is 2.764 divided by 390.5, that is 0.0839. 0.0839. Yes, 0.0839, that is alpha. Now, as we have alpha, tell me what is alpha? Alpha is actually degree of dissociation. Okay. So now Ka, that is dissociation constant of acetic acid, and that is C alpha square over 1 minus alpha. Just put the value. C is 0.00241. Alpha is 0.0839 raised to power 2 divided by 1 minus 0.0839. So now first is 0.0241, 0.00241, sorry, 0.00241, 0.00241 into 0.0839 into 0.0839 So divided by, yes, 1 minus, see, it can be written as 1.696 into 10 raised to power 1, 2, 3, 4, 5. Divided by 1 minus 1 minus 0.0839 is 0.9161. 1.696 divided by 0.9161. It is 1.85 into 10 raised to power minus 5. So this is the dissociation constant of acetic acid. Okay. Got it? So this is question number 3.11. Now, next question number 12. 12th question is very easy. See, how much charge is required for the following reductions? See, first part is 1 mole of Al3 plus to Al. See, Al3 plus. To convert Al3 plus into Al, how many electrons it gain? Yes, beta, tell me. Number of electrons gained by aluminium. Yes, Om. Yes, it is 3. So just add 3 electrons. That means 1 mole of Al3 plus. To get aluminium, we need 3 mole of electrons. So charge required is, what is the charge on 1 mole of electrons? 1 Faraday. So charge on 3 mole of, it is 3 Faraday. Yes, 3 into 96500 Coulomb. That is 3 into 96500. That is 289,500 Coulomb. Second question. 1 mole of copper 2 plus to copper. See, copper 2 plus to give copper. Shri, how many electrons are required? 2. Yes, 2. That means 1 mole of copper 2 plus. So 2 mole of electrons. That means charge required is 2 Faraday, is 2 into 96500 Coulomb. That is 196. 193, sorry, 193,000 Coulomb. So this is the value of charge in coulombs required to convert 1 mole of copper 2 plus to copper. Third one is somewhat difficult. Yes, Pranay. MnO4 negative to Mn2 plus. Not true, beta. Because MnO4 negative, in MnO4 negative, what is the oxidation number of manganese? It is plus 7. So plus 7 to plus 2. What is the change? It is 5. Yes. Or second method is just balance it first. MnO4 negative to Mn2 plus, add H2O to the side deficient of oxygen, add water to the side deficient of oxygen, and double number of H plus ion to the opposite side, and then balance the charge. See, on the left side there is 7 positive charge, on the right side there is 2 positive charge. Just add 5 electrons. So that means here charge required is 5 Faraday. That is 5 into 96 500. That is 5 into 96500. That is 482 500 Coulomb. So this is the question number 12th. Now next question. Question number 13. Question number 13 is, how much electricity in terms of Faraday? Now there is no need to convert into coulombs. Just question is, how much electricity in terms of Faraday is required to produce 20 gram of calcium from molten calcium chloride? You know, molten calcium chloride is in the form of ions. So molten calcium chloride is in the form of calcium 2 plus 2Cl negative. That is molten calcium chloride. So from calcium chloride, molten calcium chloride, we convert it to calcium. So 2 electrons. That means 1 mole of calcium 2 plus requires 2 mole of electrons, means 2 Faraday of electricity. Now means we need calcium, so 2 mole of electrons are required to produce 1 mole of calcium. So just convert 1 mole into grams, because 20 gram of calcium we have to produce. So 1 mole of calcium is equivalent to 40 gram. So 40 gram requires 2 Faraday. So 20 gram of calcium to produce, we need 1 Faraday. Just write in terms of Faraday that electricity required to produce 40 gram of calcium. 40 gram of calcium, that is equal to 2 Faraday. So electricity required to produce 20 gram of calcium, that is equal to 2 by 40 into 20 Faraday. That is 1 Faraday. This is the answer of question number 1 of 3.13 NCERT exercise question of electrochemistry. Now second part. 40 gram of aluminium from molten Al2O3. So molten Al2O3 is in the form of Al3 plus and O2 negative. So Al3 plus, from Al3 plus to get Al, electrons used are 3. That means to produce 1 mole of aluminium, 3 mole of electrons are required. To convert 1 mole of aluminium into grams, so what is atomic weight of aluminium? 27. 27 gram of aluminium produce, we need 3 Faraday of electricity, and we have to calculate for 40 gram. Just write it. Electricity produced sorry, electricity required to produce 27 gram of aluminium, that is equal to 3 Faraday. So electricity required to produce 40 gram of aluminium. So it is 3 by 27 into 40. That is 120 by 27. That is 4.44 Faraday. So that is question number 2, part 2 of 3.13 question. Yes, beta, any doubt up to this? Next question now. 14th. How much electricity is required in Coulomb for the oxidation of 1 mole of H2O to O2? See, now electricity is required in terms of Coulomb. So first part, 1 mole of H2O to O2. Just write the balanced equation first. H2O to O2. 1 mole of H2O. Now, for 1 mole of H2O to convert into O2, in 1 mole of H2O there is 1 mole of oxygen, and therefore half mole of O2 is produced. Now hydrogen, to balance hydrogen, just add 2H plus, and to balance the charge add 2 electrodes. That means 1 mole of H2O to oxidize into O2, we need 2 moles of electron. 1 mole of H2O to oxidize into O2, we need 2 mole of electrons. So electricity required to oxidize 1 mole of H2O to O2 is equal to 2 Faraday. That is 2 into 96500. That is 193000 Coulomb. Right? Now second part. 1 mole of FeO to Fe2O3. So see, in FeO, the first question we can do like this also. You know, H2O to O2 is O is 2 negative to 0. Is O2 negative to O0. So how many electrons are used? 2. This is the way. Okay. This is the easiest way to get that we need 2 mole of electrons. Now in this case, see, 1 mole of FeO to Fe2O3. What is changed? Only oxidized part is iron, Fe2 plus to Fe3 plus, because oxygen is 2 negative in FeO as well as in Fe2O3. That means in FeO, number of moles of Fe present are in the form of 2 plus is 1 mole. So Fe2 plus to Fe3 plus. So electrons involved are 1. That means 1 mole of Fe2 plus. To oxidize into Fe3 plus, it needs 1 mole of electrons. That means charge required or electricity required to oxidize 1 mole of FeO to Fe to O3 is equal to only 1 Faraday. That is 96500 Coulomb. That's it. Question number 14. Now 15. A solution of nickel nitrate is electrolyzed between platinum electrodes using a current of 5 amperes for 20 minutes. What mass of nickel is deposited at the cathode? This is the question. So, this question, to solve it, we use Faraday's first law. According to Faraday's first law, weight deposited at cathode is equal to, or is proportional to, quantity of the charge passed. Weight deposited at cathode is proportional to quantity of the charge passed. So it is proportional to quantity of charge is I into T. I in Q in coulombs. Q is in coulombs. I is in ampere and T is in seconds. Okay. And constant proportionality is Z, that is electrochemical equivalent. That is electrochemical equivalent, and its value is equivalent weight over 96,500. E over F. E is equivalent weight. So that is weight is equal to E over 96,500 into I into T. So keep in mind this relation, that weight deposited at cathode is equal to E over 96,500 into I into T. I is in ampere, T that is given. Time in second, time in minutes is given. So we convert it to seconds easily. Third is equivalent weight. Now equivalent weight is equal to atomic weight divided by number of electrons gained if it is at cathode, or lost if it is at anode. That is the way. Now we have to calculate mass of nickel deposited. So we have nickel nitrate. So nickel nitrate, in nickel nitrate, nickel is in the form of nickel 2 plus. So just write the equation that to deposit nickel, nickel 2 plus will gain how many electrons? 2 electrons. So what is equivalent weight of nickel? Equal to atomic weight of nickel. And what is atomic weight of nickel? Around 58.7 divided by 2. Equivalent weight of nickel is 58.7 and divided by number of electrons gained, that is 2. So weight of nickel deposited is equal to equivalent weight of nickel divided by 96,500 into I into T. Now I is given to you. I is 5 ampere. Yes. And time equal to 20 minutes, means 20 into 60 second, that is 1200 seconds. Just put the values. 58.7 divided by 2 into 96500 into I. What is I? Time 20 minutes, right? 20 into 60 second. So 5 into 1200. It comes in gram. The value is 58.7 into 5 into 1200 divided by 2 and divided by 96500. That is 1.825 gram. So this much amount of nickel is deposited, right? 1.825. Now next question. That is question number 16. Question is 3 electrolytic cells A, B, C containing solution zinc sulfate, silver nitrate and copper sulfate. They are connected in series. They are connected in series. A steady current of 1.5 ampere. We have 3 cells. Cell A is zinc sulfate. Cell B is silver nitrate. The solutions in cell A is zinc sulfate. In cell B, silver nitrate solution is there. And in cell C, there is copper sulfate solution. And these 3 cells are connected in series. And in these cells, a steady current of 1.5 ampere is passed through them until 1.45 gram of silver is deposited at a cathode. So cell B, at cell B, weight of silver deposited is given to you. It is 1.45 gram. So now I is given, weight of silver is given. So how long did the current flow? Can we calculate? Yes, because weight of silver deposit equal to apply the Faraday's first law. According to Faraday's first law, weight of silver deposit equal to equivalent weight of silver divided by 96500 into I into T. See, I is given, weight of silver is given, equivalent weight of silver we can calculate. So what left? Time. How long did the current flow means? We have to calculate time. The first question we can do by this relation. See, in AgNO3, Ag is in the form of Ag plus. So at a cathode, it will gain 1 electron and form silver. So what is equivalent weight of silver? Atomic weight of silver, it is 108 divided by 1. Means it is 108 only. So equivalent weight of silver is 108. Okay. So now just put the values. Weight of silver 1.45. Equivalent weight of silver 108. 96500 into 1.5. into T. So in this way, T is equal to 1.45 96500 divided by 1.5 into 108. 1.45 into 96500 divided by 1.5 divided by 108. It comes out to be 863.7 seconds. So that is the time. Okay. Now next is what mass of copper and zinc were deposited. See, they are connected in series. If they are connected in series, see, as cells are connected in series. If cells are connected in series, means quantity of charge passed is same. Quantity of charge passed through them is same. It means weight of, what is the weight of? Okay, zinc. Weight of zinc deposited at cell A, at cathode of cell A. So it is equivalent weight of zinc divided by 96500 into I into T. Quantity of charge passed the same is I into T is same. It means I into T. It is same. Next, on cell B, weight of silver equal to equivalent weight of silver over 96500 into I into T. At cell C, cell C is copper sulfate. So weight of copper deposit is equivalent weight of copper over 96500 into I into T. So from here, from 1 and 2, weight of zinc divided by weight of silver is equal to equivalent weight of zinc over equivalent weight of silver. This is Faraday's second law. This is Faraday's second law, that ratio of the weights deposited is equal to ratio of their equivalent weights if cells are connected in series. And from 1 and 3, from 2 and 3, weight of copper divided by weight of silver equal to equivalent weight of copper over equivalent weight of silver. In this way, we can calculate weight of zinc as well as weight of copper. See, in zinc sulfate, it is zinc 2 plus 2 electron to zinc. So from here, equivalent weight of zinc is atomic weight of zinc, that is 65 divided by 2. And copper sulfate, copper 2 plus 2 electron, copper, equivalent weight of copper is 63.5 over 2. Yes, Yash, hi beta. Okay. So just use this relation. Weight of zinc over weight of silver equal to equivalent weight of zinc over equivalent weight of silver. Or we can write weight of zinc equal to equivalent weight of zinc over equivalent weight of silver into weight of silver. So weight of zinc is equal to equivalent weight of zinc, that is 65 over 2, equivalent weight of silver, that is 108, and weight of silver. So weight of silver is 1.45. Wait, 1.45. So it is 65 into 1.45 divided by 2 divided by 108. That is 0.436 gram. That is the weight of zinc the positive. Next, weight of copper over weight of silver equal to equivalent weight of copper over equivalent weight of silver. That is, weight of copper is equal to equivalent weight of copper over equivalent weight of silver into weight of silver. Just calculate. Equivalent weight of copper is 63.5 over 2. Equivalent weight of silver is 108. And weight of silver deposited is 1.45. So it is 63.5 into 1.45 divided by 216. It is 0.426 gram. First one was 0.436 gram and second is 0.426 gram zinc and copper deposited. So this is question number 16. Now only two questions left. Question number 17. Using the standard electrode potentials given in table 3.1 is question when it is asked, it is not written, it is given in table 3.1. The values are given to you. So just write the values. Means those E naught values should be given to you. Okay. So E naught, wait, I will write the values. E naught I to I negative value is 0.541 volt. E naught copper 2 plus copper 0.34 volt. E naught of Br2 Br negative 1.09 volt. E naught Ag plus Ag 0.80 volt and E naught Fe3 plus Fe2 plus, that is 0.77 volt. These values should be given to you. Okay. So now, how do we relate them? Is it feasible or not? What we do? You know delta G naught. What is the relation between delta G naught and E naught? Oh, wait. Okay. Relation between delta G naught and E naught. So delta G naught equal to minus NF E naught cell. For the reaction to be feasible, delta G naught is negative. So delta G naught negative, so E naught cell should be positive. So just we have to calculate E naught cell of each pair. If it is positive, reaction is feasible. If it is negative, reaction is not feasible. And if it is equal to 0, that means it is at equilibrium. But that is not the case. Okay. Hello. Yes. So what I said, if E naught cell is positive, then reaction is feasible for the pair. If E naught cell is negative, reaction is not feasible. E naught cell, if it is positive, reaction is feasible. If E naught cell is negative, reaction is not feasible. And if E naught cell is 0, then reaction is at equilibrium. This is not the case here. Okay. So just do it for first pair. Fe3 plus I negative. Fe3 plus I negative. So you know Fe3 plus, that is converted into Fe2 plus I negative into I2. That means, let us say half I2. So Fe3 3 plus minus 1. Total plus 2. Here also plus 2. So what is E naught cell in this case? Just calculate E naught cell. Just calculate E naught cell. What is E naught cell? E naught cathode minus E naught anode. And what is cathode here? Cathode is Fe3 plus to Fe2 plus, and anode is I negative to I2. Just do it. E naught cell is equal to E naught Fe3 plus to Fe2 plus minus E naught I negative to I2. What is the value? I2 to I negative, sorry. So E naught Fe3 plus to Fe2 plus, value is given 0.77 volt minus 0.541 volt. It comes out to be 0.229 volt. That means E naught cell is positive. E naught cell is positive. So reaction is, yes beta, E naught cell is positive. So that means reaction is, yes, reaction is feasible. So that means this reaction between Fe3 plus and I negative, it is feasible. Reaction between Fe3 plus and I negative is feasible. Come to second. Ag plus, feasible means that reaction, the reaction which takes place by its own, means Fe3 plus is reduced and I negative is oxidized in this reaction. Means spontaneous. Feasible means spontaneous. Reaction which takes place by its own without the help of external agency. We need Fe3 plus and I negative only, and reaction can take place. Got it? Okay. Now second pair is Ag plus and copper. So Ag plus, obviously it will gain one electron, and copper, that will lose two electrons. So in this case, silver is cathode. There's no need to write balanced equation, I think. Silver is cathode, copper is anode. So E naught cell is E naught cathode minus E naught anode. E naught cathode E naught cathode minus E naught anode. So E naught cathode is silver, E naught copper. Silver is, its value is 0.80 volt, and for copper it is 0.34 volt. So 0.80 minus 0.34, that means 0.46 volt. So it means E naught cell, it is positive. So reaction is feasible. His reaction between Ag plus and copper is again feasible. First two reactions are feasible. So first two reactions, they are feasible because in both the cases E naught cell is positive. Now come to next. Next one is Fe3 plus and Br negative. Fe3 plus and Br negative. So Fe3 plus to Fe2 plus, that is cathode. Fe3 plus to Fe2 plus, it is cathode. Br negative to Br2 anode. So what is E naught cell for this reaction? E naught cell is E naught cathode minus E naught anode. And what is the value for Fe3 plus to Fe2 plus? Minus 0.77 volt, and it is minus 1.09 volt. Am I right? Yes, 0.77 volt and 1.07 volt. So this value comes out to be negative. It is minus 0.32 volt. So what about this reaction? Is this reaction feasible? Reaction is, yes beta. What about this reaction? Is it feasible or not? This reaction, is it feasible? Yes beta. Is this reaction feasible or not? Very good. E naught cell is negative, so this reaction is not. This reaction is not feasible. Means this reaction between Fe3 plus and Br negative is not feasible. Now, fourth pair. Fourth pair is Ag and Fe3 plus. Ag and Fe3 plus. Now Ag is converted into Ag plus and Fe3 plus to Fe2 plus. The Ag converted into Ag plus. That means it acts as anode. And Fe3 plus gain one electron. To get Fe2 plus, it acts as cathode. So what is E naught cell? E naught cell is E naught Fe3 plus Fe2 plus minus E naught Ag plus Ag 0.77 minus 0.80 minus 0.03 volt. So what about this reaction? This reaction, is it feasible or not? Yes, it is not feasible. This reaction is not feasible. Now fifth one. Fifth pair is Br2 Fe2 plus. So Br2 is converted into Br negative. So it will gain electron, and Fe2 plus so now what happened? This one act as cathode because gain of electron is reduction takes place. It acts as a cathode, and this one as anode. So what is E naught cell? E naught half Br2 to Br negative minus E naught Fe3 plus Fe2 plus. It is 1.09 minus 0.77. 1.09 minus 0.77. 0.32 volt means this reaction is feasible. So this is question number 17. Okay, this is question number 17. Now last question of this chapter, that is 3.18. This question is in class 11th as well, in redox reactions. Predict the products of electrolysis in each of the following. First one is an aqueous solution of silver nitrate. An aqueous solution of silver nitrate with silver electrodes. And second one is an aqueous solution of silver nitrate with platinum electrodes. See, here there are two types of things. First is silver nitrate with silver electrodes, silver nitrate with platinum electrodes. Okay, silver nitrate with silver electrodes, silver nitrate with platinum electrodes. Silver nitrate with silver electrode means electrode is attackable. Electrode is attackable. So as electrode is attackable, so at cathode as well as at anode, silver is active. See, in aqueous solution of silver nitrate, we have Ag plus, NO3 negative. Okay, and solution is aqueous, so there is H plus as well as OH negative. Okay, so now just say at cathode. At cathode we have Ag plus and H plus. So keep in mind, when Ag plus and H plus are there at cathode, discharge potential of silver is less than hydrogen. Discharge potential okay, discharge potential of silver, the Ag plus, is less. Charge potential of Ag plus is less than that of H plus. Okay, so at cathode, silver plus will gain electron and silver is deposited at a cathode. Now come to anode. At anode, there are NO3 negative ion, OH negative ions, and silver is electrode, that is attackable. So nitrate attack silver ion and therefore silver is converted into silver nitrate. Silver is converted into silver nitrate. That means at cathode and at anode, silver is dissolved. So overall, what is the product of electrolysis in each of the following? In first case, when aqueous solution of silver nitrate is there with silver electrodes, then when silver electrode is used, silver is an attackable electrode and therefore at cathode silver is deposited and at anode silver is dissolved. At cathode silver is deposited and at anode silver is, yes beta, silver is dissolved. That is the case. So first, in case at cathode silver is deposited and at anode silver is dissolved. Now second part, when silver nitrate we have and silver nitrate using an aqueous solution of silver nitrate using platinum electrode. Beta, platinum is non-attackable electrode. Platinum is non-attackable electrode. Okay, that's why at cathode same reaction takes place. That is Ag plus gain one electron and we get Ag solid. At anode, there are nitrate and OH negative ion. So out of nitrate and OH negative, discharge potential of OH negative is less than nitrate. So OH negative ion give OH and then OH give H2O, O2, So overall reaction is 4 OH negative ion to give 2H2O plus O2 plus 2 electron. So we will say that at cathode silver is deposited, and at anode oxygen is released. At cathode silver is deposited, and at anode O2 is released. So in this case, when platinum electrode is used, at cathode silver is deposited, and at anode O2 is released. That is the second part. Now third, electrolysis of a dilute solution of H2SO4 using platinum electrodes. We have dilute H2SO4. Dilute H2SO4. So in dilute H2SO4, we have H plus ion, SO4 2 negative ion, and OH negative ions. These are the ions. Okay. So obviously at cathode there is no competition. We have only H plus ions. So that will gain electron and we get H2S gas. Okay. H2 gas. Now at anode there is a competition. We have sulfate ion, and OH negative ion. Sulfate ion and OH negative ion. Now out of sulfate ion and OH negative ion will lose electrons. Same reaction takes place. 4OH negative, 2H2O plus O2 plus 4 electron. So that is the case. Just like in this case. There are 4 electrons. 4OH negative, 2H2O plus O2 plus 4 electron. Same reaction takes place here also. Cathode H2 gas is released, evolved, and at anode O2 gas is evolved. At cathode H2 gas and at anode O2 gas. Last part. The last part is an aqueous solution of CuCl2 with platinum electrodes. CuCl2. So aqueous solution of CuCl2, we have Cu2 plus, Cl negative, H plus, OH negative. H plus and OH negative in aqueous solutions are by default because water is there. So now at cathode, obviously we have copper 2 plus and H plus. So copper 2 plus, discharge potential of copper 2 plus is less than H plus. So at cathode, copper 2 plus will gain electron to give copper. It depends upon the reduction potentials, okay? At anode, we have Cl negative and OH negative ion. Keep in mind, Cl negative ion will lose electron. We get Cl2. In this way, copper is deposited at cathode and Cl2 gas is released at anode. So keep in mind, in case of cations at cathode, silver rate of deposition, silver, copper greater than H plus, and rest of the elements are sodium, zinc, nickel, all they are below it. Keep in mind silver and copper, they are deposited in place of H plus, and rest of the ions are like that only. At anode, Cl negative, OH negative, then sulfate and nitrate. Okay, the Cl negative and lose electrons first, then OH negative, then sulfate and nitrate. Okay, so whenever sulfate and nitrate are present, OH negative ion will only lose electrons. See, in this case, sulfate is there with OH negative, so we use OH negative ion that will lose electron. In this case, nitrate and OH negative was there, so OH negative ion lose electron. But in the last case, chloride and OH negative ion competition there, so Cl negative ion lose electron. Okay, so keep in mind these two orders that will help you to predict products of electrolysis. Okay, so that's all the day. Thank you so much to all of you. So these are total 18 questions that we have done today. Is from 5th to 6th to 18th. Okay. Done, beta? Any doubt in it? Any doubt? I said any doubt up to this? We have done from 3.6 to 8. No doubt. See, Pranay. Pranay. Any doubt, beta? Okay, then bye bye. So thank you so much to all of you. If you have any doubt, please do ask my YouTube subscribers, because I have now chats are allowed for the subscribers only, that I did this year, because if you are my subscriber, you will get an advantage that you can chat with me. Non-subscribers not be allowed to chat. So share with your friends and ask them to share further and subscribe my channel, so that we have a community of 1 lakh subscribers, and that is really an asset to me, and I love to teach. So I want all of you to be the part of this drive, free education drive, and it's all free of cost. I will do all the NCERT concepts as well as NCERT exercise questions. At the same time, we will do NEET and JEE questions as well. So this is all free of cost. So take this as an opportunity to learn more free of cost. Ask your friends to join. We are here from 7 to 8 every day, almost every day. So wait for the sessions and do join every day, so that you will get a benefit, and ask your friends to be, so that they will also be benefited by free education. You are not charged single penny. There's no need to go to tuition center, give hefty amount of money. Will get free education on my channel. So be with me and support my channel. Thank you so much to all of you. Bye bye, beta.